Let's see how we can do this in the Excel. The Excel offers a number of tools to facilitate what-if analysis. So in this section, we introduce 3 tools: data tape, data table, goal-seek, and scenario manager. All of these tools are designed to rid the users of tedious manual trial or error approach to analysis. So the data table in the Excel tools that quantify the impact of changing the values of the specific input on an output of the interest. And it can generate either a one-way to data table, which summarizes a single input's impact on the output, or a two-way table, which summarizes 2 inputs' impact on the output. And before we do so, we need to generate the spreadsheet model, including parameters and models. So in our case, the 3 parameters are manufacturing fixed cost, manufacturing variable cost per unit, and also the outsourcing cost per unit. So we put it in under the parameter on top of the spreadsheet models. And then in the model, the first thing we have to input is the decision variable, which is the quantity. And last, we input the calculations. Since the saving due to outsourcing is calculated using the total cost to produce minus the total cost per outsourcing. So we can organize our spreadsheet models like with the 3 different rows, including all of them. And we have the numbers in column B that's related to each parameters. And we highlight the decision variable here to tell viewers or stakeholders that this is the decision variable that can impact the result of the models. And we can change the number here to see the result change under the models. And at the same time, the total cost to produce is calculated using the manufacturing fixed cost and the manufacturing variable cost per unit. And the same way, the total cost to outsourcing is using the outsourcing cost per unit with the quantity, which is our decision variable, to calculate it. And then we have saving due to outsourcing, which is calculated by produced minus the outsource. And as a result, since the parameters are all fixed values, they will never change, and they are all included in our calculations. But at the same time, the quantity is changeable and is also in our calculations. So every time we change the quantity, the result of the calculations will be changed. So the only thing we will do is we will find in which number of the quantity can give saving due to outsourcing more than 0, but as very close to the 0. So let's do this one-way table to see how we can do it. The first step in creating a one-way table is to construct a solid list of the values you would like to consider for the input. So let's investigate the quantity Q over a range from 0 to 300,000 in increment of 25,000 units. The figure shows we have entered this data in cell D5 through D17 with a column label in D4. And this column of the data is the set of the value that Excel will use as input for Q. As a result, since the output of the interest is saving due to the outsourcing located in cell B17, we have encountered that formula equals to B17 in cell E4 to make sure that this is the result we will have based on the quantity change. In general, set the cell to the right of the label to the cell located at the output variable of interest. So once of the basic structure is in place, we invoke the data table tool using the following steps. So we can select cells D4 to E17 and click Data tab in ribbon, click What If Analysis in the forest group, select Data Table. And when Data Table dialog appears, enter B11 in the column Input Cells and then click OK. So we can see that this table provides a clear picture of how savings change as production levels vary. For smaller quantities, such as from 0 to 100,000 units, the savings values are positive, meaning that the outsourcing is more economical. And the breakpoint occurs between approximately 125,000 and 150,000 units. At 150,000 units, savings are around $9,000, indicating that the cost of the manufacturing and outsourcing are nearly equal. But beyond this threshold, the savings become negative, showing that the manufacturing becomes cheaper. At the higher production levels, such as the 200,000 units, the savings fall to negative $66,000, and at the 300,000 units, the decrease further to negative $216,000. So this result demonstrates that the manufacturing provides a significant cost advantage when production volumes are large. So from a business perspective, the company should continue outsourcing if the expected production is below approximately 150,000 units, and since outsourcing production leads to cost saving. However, if the demand is projected to exist this level, manufacturing becomes the more cost-effective strategy due to the lower variable cost per unit. And now, let's suppose that the Liaoning has received 5 different bids on the per unit cost for outsourcing the production of the Viper. So clearly, the lowest bid provides the greatest savings. However, the selection of the outsource firm, if Liaoning decided to do outsource, will depend on many factors, including reliability, quality, and on-time delivery. So it would be instructive to quantify the difference in savings for various quantities and bids. And the 5 current bids are $2.89, $3.13, $3.50, $3.54, and $3.59. We may use the Excel data table to construct a two-way data table with quantity as a column and 5 bids as a row. So in this figure, we have entered the various quantities in cells D5 through D17 as in a one-way table. And these correspond to cell B11 in our model. And in cells E4 through I4, we have entered the bids. And this corresponding to B7, the outsourcing cost per unit. And in cell D4, this is a little bit different with the one-way table, because in the one-way table, we put the formula equals to B17 on the E4. But here, since we have E4 to I4 as the represented the values of the bids, so we will put the formula 0B17 in D4, which is the location of the output of interest. And so once the table's inputs have been entered into the spreadsheet, we perform the following steps to construct a two-way data table. So similar as before, we select cells from D4 to I17. Click the Data tab in the ribbon. Click What If Analysis in the Forecast group and select Data Table. And when a Data Table dialog box appears, we have to put B7 in the row input cell box and B11 in the column input cell box, because we are using both the quantity and outsourcing cost per unit as the decision variable to decide the saving due to the outsourcing. And then we click OK. So this figure shows the selected cells and data table dialog box. So we can tell from this table, the positive values indicating the outsourcing is more cost-effective, while the negative values indicate that in-house manufacturing is cheaper. And the key observations reveal that when outsourcing costs are low, such as 2.89 cents per unit in column E, the savings remain positive for a wider range of quantities. And so in contrast, when outsourcing costs are high, such as $3.59 per unit in column I, savings become negative much easier, making the in-house production the preferred choice for the large range of the quantity. So this analysis highlights how the cost effectiveness of outsourcing versus in-house production depends not only on the quantity required, but also on the per unit outsourcing cost. So now, the last tool we will learn is called Excel Go Seek, which allows the users to determine the value of input cells that will cause the value of the related output cells to equal some specific value, which is the goal. And in our case, suppose we want to know the value of the quantity of the Viper at which it becomes more cost-effective to manufacturing rather than outsourcing. So which means we want to know that exact threshold of the quantity to make the saving due to outsourcing is 0. And that also means the cost to produce is equals to the cost of outsourcing. And to find that exactly value, what we will do is we're using a Go Seek. So we can click the Data tab in the ribbon and click What If Analysis in the Forecast group, select Data Seek, and select the Go Seek. And when the Go Seek dialog box appears, we will enter B17 in the Set Cell box, because that is our target, right? That is the result we want to know. And we set these results to 0, so we put 0 to 2 value, is because we want to know at which time, at which quality, the cost to produce is equals to the cost of our sourcing. And since the saving is using the produce minus outsource, so when the produce and outsource cost are equal, and the saving should be 0. And that's the reason we will set 0 to the value. And then we will enter B11 in the by change cell, is because B11 is our decision variable, which is the quantity, right? So we want to know how quantity change can impact the savings to 0. And then we click OK. So after we click OK, we can see the result shown here already. And based on this result, we can tell that at 156,000 units, the total cost of the in-house production and outsourcing are equal. And so that is the threshold. Means that for the quantities below 156,000, outsourcing is better option because the fixed cost of in-house production are too high to be spread out efficiently. And then for the quantities above 156,000, the in-house production becomes cheaper as fixed costs get distributed over more units, reducing the per unit cost. So how do we implement Scenario Manager in Excel? So first of all, we have to create a spreadsheet that can represent Middletown Assumed Park daily profit model. So first of all, in A1, let's input Middletown Assumed Park. And then at A3, we will create a parameters model. Whereas under that, we will have admission price, and then we will have the value as $35. and then number of the season pass holders admitted, which is 3,000 for partly cloudy, and admissions would be 1,600 per day. And then average expenditure for season pass holders is $15, and admissions will be $45. Then we have another fixed variable, which is the cost of the operations, which is $33,000 per day, and 50% of profit as the cost of the good. And then we will have models, including the admission revenue. So you might notice here that there is no decision variable, right, comparing to the table. But you have to remember that this is a scenario manager. The scenario itself is the decision variable. So we will have 3 different scenarios here. As a result, we will change those decision variables based on the scenario instead of some specific data. So as a result, we don't have the decision variables showing in the spreadsheet model yet. So right now, we are finishing those calculated variables, including admission revenue, which is using admission price multiplied by the amount of the people who are admissions. And then we have season pass holders expenditures revenue, which is the number of the season pass holders multiplied by the average expenditures of the season pass holder. And same thing, we have the admissions expenditures revenue, which is the amount of the admission multiplied by the average expenditures of admissions. And as a result, we can calculate the total revenue, which is the sum of all admission revenue and both expenditures revenue for season pass holders and admissions. And in addition to revenue, we also have the cost. So we have the cost of operations, and we also have the cost of the goods, which use the percentage multiplied by the sum of the expenditures revenue. So total cost would be the sum of the both costs. And as a result, we'll have the profit, which is the total revenue minus the total cost. And then we will create a scenario. So to create a scenario, we have to go to click the data tab in the ribbon and click what if analysis in the forecast group and select scenario manager. And when the scenario manager dialog box appears, we have to click add button to add the scenario. So you can tell here, you are asked to enter the first name of the scenario. So we will have the partly cloudy in a scenario name. And then we will enter B6 to B9 and B11 in changing cell box, because those are the variables that could be changed or impacted by the scenario, right? So B6 to B9, that is admission price, number of the season pass holder admitted, admissions number, and average expenditures for both season pass and holders and admissions. And then don't forget about the cost of the operations because that's also the fixed parameters. So come back, we will add the values in this scenario to make sure that these are the values of each parameters under the partly cloudy scenario. All right, and then we click OK. And then we will add another scenario. So based on this table, we will have those parameters, the value of those parameters under the rain scenario and also under the sunny scenario. So you will repeat the same process to add the values under each of the scenarios. So when you have done all of this, you will have 3 scenarios in the scenario manager box, including partly cloudy, rain, and then sunny. So when all the scenarios have been entered and the scenario manager dialog box appears, you will click the summary. And when the scenario summary dialog box appears, we will select the scenario summary and enter B25 in the result sales box to click OK. Because the B25 is the profit, which is the output that we're looking for. And at the end, you will see that there is a scenario summary report appears on the separated worksheet as shown here. And this summary includes the values currently in the spreadsheet along with the specific scenarios.